Hey friends, welcome to the Electrostatics Review Day 3. I hope the PSAT went well for you yesterday and that experience is good. I'm sure you had a long afternoon to kind of reset, breathe a little bit, and get ready for Day 3 here. So it's E-Day, it's Friday. This is our Electrostatics Review of the things that we learned earlier in the week in the two sessions on Tuesday and Wednesday. So first off, check out the key to the force worksheet. Make sure you look at the key to the electrostatics force worksheet. Again, there's no quiz today. There won't be a quiz for this unit. There will only be the test next Friday. You do have a test next Friday, normal test, electrostatics. Next week, we'll be doing a lab. Next week, we'll be doing review, a little bit more review, kind of me going over some of this stuff with you in person to make sure we're all set for the test on Friday. But so far, we are all caught up. We are right on track with where we need to be. We're just going to do the lab from this week, next week, day 1, and then we'll be reviewing and getting ready for that test on day 3. Okay, so what have we talked about? We've talked about electric field, we've talked about electric force, we've talked about charging. Check out the keys. Make sure you guys are okay with those keys to those worksheets. How'd you do on the force one, the one that was a little bit tricky, the triangle one, where you had two positives and a negative, and it said, what about the force on that negative charge? That was a little bit tricky because we didn't do an exact one like that. I talked about 3 charges in a row, the force on the middle charge and how it would get pushed left or right. But what about this one where you do the force on the negative? What does that negative want to do? Well, this is a little bit tricky. That negative, is it attracted to the red positive or repelled? It's attracted. So it's going to go that way. That negative, is it attracted or repelled from the blue positive? It's attracted. But what happens if I'm doing like this, like tug of war? Well, if it's tug of war and one's going down to the left and one's going down to the right, guess what's going to win? Straight down. That's a little bit of a tricky question, but hopefully you got that. The force would be straight down. How about the next one where you've got 4 positive charges and you want the force on B due to A, C, and D? Well, this is a little bit tough too. You got 4 charges. What do? Well, I just say, hey, look, B. Does B want to go towards the red one or away from it? It wants to go away. Does B want to go towards the blue one or away from it? Well, again, likes repel. So B wants to go away. Does B want to go towards C, that positive, towards it or away from it? Away. It's still repelling. B is repelled from A to the right, repelled from D up, repelled from C up to the right. So with these 3 forces, imagine tug of war. Imagine you're getting pulled up, you're getting pulled right, and you're getting pulled up to the right. Which way are you going? You're going this way big time. Because the 2 that are up and to the right are going to make it up to the right. The one that's up to the right is up to the right. So everything's going up to the right. That's the way that force is going to go. So hopefully you handled those last 2. And if not, we'll review this more next week. We're going to go ahead and start the review process today, though. You have a review worksheet due today. Shouldn't have homework for the weekend. This is a long period, a normal period. You should be able to get this lesson in, this review session in, and then be able to do that. So you had your electrostatics like introduction worksheet on day 1. You had your force on day 2. Now we're doing the review. We skipped over the lab. That'll be day 1 next week. And then we'll review again as we get ready for the test. So here's a review of what we've done this week so far. Okay. That should have helped you with that. For your review worksheet, the one today, there's a lot of things on it. Let's talk. If 2 things are neutral and they rub together, if one becomes positive, the other must be negative. That's true. If 2 things rub together and one becomes positive, the other must be negative. You can't rub 2 things together and they're both positive if they were neutral to start with. You can't take 2 neutral things, rub them together, and they're both negative. If one's negative, the other's positive. That's the conservation of charge. That means the universe is electrically neutral. If one thing becomes negative, another thing must have become positive. What about there? Towards the end, there's some funky questions. A lot of it is review of the stuff you've already done. But what if I gave you a question that said, hey, look, you got a charge like this. This is towards the end of the review. You got a charge like that. Those are the field lines for the charge. Is the charge negative or positive? Is that charge negative or positive? Well, I have to remember that field lines move away from positive and towards negative. That's a negative. If I had one that looked like this, where it's going like this and it says, hey, are these field lines from a negative or positive? What is that charge in there? What is this? It's kind of working backwards. The review sheet challenges you a little bit. What if I have the red image and I say, what's that charge? That charge has to be positive. That charge has to be positive. What if I gave you one that said, hey, look, you've got this guy, and the field lines are going like this. Whoops, that last one's no good. So what if the field lines are doing that? Which charge is positive, which is negative? Are they the same? I don't even know yet. Well, in this case, if the field lines are going towards that left charge, this has got to be negative. If the field lines are leaving this charge, if they're leaving that charge, that's got to be positive. Where field lines leave, that's a positive charge. Where they enter, that's a negative. So field lines go from positive to negative. I don't know if we did the other day like charges. What if I had two positive charges? Do you know why they repel? One of the reasons they repel? Look at their field lines. Field lines go towards each other, but field lines can't cross. So when the field lines go for positives, they're actually going to do like this. So field lines can't cross over each other. So field lines move away from positive and towards negative. But if field lines are moving away from positive and can't cross over each other, then they start to push off each other. Negative charges, if I had two negatives, their field lines would do the same thing as the positive. Why? Because they repel the same as two positives repel. The only difference is their field lines move towards them. So two positives and two negatives have the exact same field lines. It's just that the lines for the negative point towards the charge, the lines for the positive point away from the charge. So if you ever see some funky lines like this, it's either two positive or two negative. Those field lines don't cross, and as I get them closer and closer and closer, the field lines push off of each other. So that's what the field lines look for those guys. Again, things like opposites attract, likes repel. Things like if I have, how about this? A negative 2 Coulomb charge, a positive 6 Coulomb charge, and a negative 8 Coulomb charge. And I said something like, hey, what's the force? This is going to be tricky. What's the force on the 2 due to the other ones? Force on the 2. Oh, I don't want to say other 2 like that. I want to say other 2 charges, so it's not confusing. 2 charges. What is it? What about the force on the 2? What does that 2 want to do? Well, the 2, is it attracted? Is the 2 attracted to the 6 or repelled from it? The 2 is negative, the 6 is positive, so the 2 wants to go towards the 6. But because the 8's negative and the 2 is negative, the 2 is going to want to go away from the 8. So then I got to figure out who's going to win. What about the 6? The 6 is tricky because the 6 wants to go left towards the 2, right towards the 8. The 6 is pretty easy because the right's going to win. If I want to know which way the 6 is going to go, it's going to go right because it's attracted more to the 8 than it is the 2. The 2 would be a little bit difficult for a test question because the 6 would probably win because it's closer, but the 8 is bigger. So the 2 would actually be a really tough question for a test question. Probably would leave that one out because it's really hard to tell which. The 8, though, the 8 is probably going to get more attracted to the 6 than it is repelled from the 2. So the 8's probably going to want to go left. So look for some of these ones where it's like, hey, if it's force, what does this one want to do? Is it attracted? Is it repelled? What does this one want to do? If it's field is all about moving away from positive and towards negative. So you may have some of these ones where you got to guess what the charge is inside those field lines. Okay, so that probably should be just about enough for your review. Make sure you know about, again, the lightning cloud. Top of the cloud's positive, bottom is negative. The ground gets very, very negative. That's important for this. When two things are rubbed together and they were neutral, one has to become positive, one has to become negative. Things like the charge, the units for charge are coulombs. The universe, true or false, is electrically neutral. True, true. How about this? If something becomes charged positively, did it gain protons? If something becomes charged positively, did it gain protons? False. If something becomes positive, it's because it lost electrons. It's all about the electrons. If something becomes positive, it lost electrons. If something became negative, it gained electrons. You either gain or lose electrons. It's all about the electrons. Okay. So that should be enough for your review. If you missed any of the days earlier in the week, make sure you get those other assignments in. You've got this time now to knock out your review packet, get it submitted into Canvas. You should have no homework over the weekend. You have had 3 total worksheets this week: the introduction on day 1, the force on day 2, and now the review on day 3. Make sure those are all in and ready to go, because when I come see you day 1 next week, when I come back next week, we're going to get right into checking all these worksheets and making sure we're good. Taking any questions. We're going to do a lab on day 1. We have our lab activities on day 1 with electrostatics and charging balloons and different objects. We have a lab on day 1, and then just kind of open review on day 2 as we get ready for the test on day 3. So we're actually in really good shape. This is the whole chapter. I mean, you guys have covered it. This is all of it. We just have to do a little bit of a lab to get that activity going, and then any last questions for review to get ready for an electrostatics test. It's all about field and force, charging by friction, field lines, and the direction of forces on charges, how storms work. So again, lab on day 1, review again on day 2, just to talk about it, and we'll have a test on day 3 next week. I'll see you guys soon. Sorry I missed you this week. I hope the PSAT went well yesterday. Get your homework done. Good luck. Love you. Hags. Is Hag still a thing? I don't know. Have a good weekend. Hagwa? Hagwa? See you soon, friends.